part is to actually be able to analyze the data when you get it. So for example, all right, just a second. Do this. So you will typically get a chart like this. And you have the relative abundance on this side.
That
Right, so for the first thing, right, this mass spectrum, there are three important fragments on it that you must be able to identify. So the heaviest peak, so if you notice, right, you have the numbers on it, 15, 29, 43, 57, and 72. The heaviest one is always at the end. And that one is your molecular ion peak. All right. The tallest peak now, which is this one here. So the tallest peak, we refer to it as the base peak. And the tallest peak, it is your most stable fragment. So the base peak, it is the most stable fragment. Now, some mass spectral data, not all of them, right after the molecular ion peak, you will see a short line after it. So this line, right after the molecular ion, and you will not see a number in it. That is referred to as the M plus 1 peak. So the molecular ion peak, that is the M plus peak, right? So remember now, an ion is formed when any species loses an electron. So if you have an atom, the atom loses an electron, you get an ion. So during the process, I can look at the procedure. When the molecule loses an electron, that's how you get the molecular ion. So for tonight, we are focusing on this chart here and others, right? So the first thing you should be able to do is to identify your base peak, that is always the tallest one, and your molecular ion peak, that is the heaviest one. They ask about an M plus 1 peak. You look for a tiny peak just after the molecular ion. So typical questions that they can ask, all right? Apart from identifying these three peaks. All right, so those are the typical questions for you to be able to draw these fragments, 15, 29, 43, whichever fragments you get, you should be able to draw the structure for it, right? And as well as the structure for your molecular ion. The question will have to tell you if you have a hydrocarbon, a alkyl alkane, alcohol, carboxylic acid, or an ester. So you can get mass spectra, can get it for hydrocarbons, like this example, that's a hydrocarbon. You can get it for haloalkane, which we will do. And ester. You can get it for any of those compounds. All right. So starting off now, I'm going to show you how you can do it. You can figure out these structures quickly. All right. So I'm going to start with the molecular ion. So this is the mass spectrum of a hydrocarbon. So they will tell you which compound you are dealing with. So for this one, I am telling you that it is hydrocarbon. So the first thing I'm going to show you is how to get the molecular ion peak. All right. I'm going to erase the right-hand side of the board, which is these questions. So you can just take a picture of it. All right. I'm going to erase it. All right, so it says if we want to find the formula for the molecular ion of a hydrocarbon, you are going to divide the mass of the molecular ion. So in our example, the mass of the molecular ion, that is 72. And you are to divide it by the mass of carbon. You know, the atomic mass is 12. So 12 divided by 72 divided by 12 is 6. And then you are going to subtract 1 from it. So our compound has in 5 carbon atoms. All right. So we know that our hydrocarbon is pentane, which would be C5H12. If you check the mass of this, it should match up to 72. So we know 12 5 is 60, 60 and 12, that is 72. So this particular hydrocarbon, it is pentane, right? So that is what you will do. If you get a hydrocarbon and you need the formula for it, just divide by 12, then subtract 1. If for some reason you get a decimal, so for example, if it was 6.7, 6.4, 6.9, ignore the decimal. So it would, in each case, your answer, you divide by 12, is 6. So you're going to ignore, if in any instance you get a decimal, not pay it any mind. All right. So that is what you would do for your molecular ion. I'll give you a minute to write and then I erase the right hand side of the board. I'm going to erase now. You can take a screenshot or a picture if necessary. I'm just erasing the right hand side. Now, how do we find the formula of our fragments? So the 57, the 43, 29, and 15.
Sir, are you speaking?
Oh, All right, so if you remember with the molecular ion, we would divide by 12. Whatever answer we get, we subtract 1 from it. With the fragment, it's different, just a little different. So let's work 57. So it would be 57 divided by 12. The answer is 4.8. And notice I said that you do not round off. So if I get 4.8, just focus on 4. So the fragment that is 57 has 4 carbons. All right. So that would be C4. Now, get the frag to get how many hydrogens? Just know that it is 1 less than the alkane. For example, C4, if it was an alkane, it would be C4H, and it should be 1 less, so C4H9. But of course, you could just say 12 times 4, that is 48. 48 from 57, that would give you 9. Some comments. So for the molecular ion, would we round off? No. The first texting, I don't use that formula. I didn't use it because this way is easy to get your answers. All right. So that would be for fragment 57. I soon show you exactly why it has to be 9. All right, let me show you now. So we know that the molecule is pentane. Pentane has 5 carbons. So I'm going to draw the molecule of pentane down here. So 5 carbon, 12 hydrogens. So 5 carbon. So this is pentane, right? Remember, when your molecule goes into the mass spectrometer, some of it will break up into fragments. The molecular ion means that it did not break up. So the entire pentane molecule made its way through the mass spectrometer. However, if it fragments, let's say fragments here, you're breaking the carbon to carbon bond, right? So at no point would have the correct amount of hydrogen to make it an alkane. Because you're breaking the carbon to carbon bond here, it will always have 1 less hydrogen. So for example, if you have an alkane with 3 carbons, it should have 8 hydrogens. Look at this here. For the first 3 carbons, 1, 2, 3, it has 3 and 2, 5 and 2, 7 hydrogen. Because this bond here is to a carbon. So that is the reason why you should always have 1 less hydrogen. All right, because you are always breaking carbon to carbon.
Mama, what did I do to you? You are very lucky I am not here with
All right, so you can to quickly get it once it's 4 carbons, You just do it like the alkane. No, it should have one less hydrogen. All right, and that's it. And I'm going to do 43 now. I'm going to erase the top right hand side of the board. All right, so to move a little quicker now, it's just 43 divided by 12. You will get 3 point something. Let me check 3 point how much. That is 3.6. Again, you do not round off. It is 3 carbons. So that means this would be C3H7. Right? And these formulas we always put a positive sign on them. All right. 29. So fragment 29. It will be 29 divided by 12. You will get 2.4. So we know it has 2 carbons. So C2H5. All right, to the person on the channel, this we divide by 12 because that's the mass of carbon. It's just a way of finding the formula quickly. All right. So I just figured out a way how to do it. All right. So I can't give you an exact rationale, but it works. All right. And then 15 divided by 12 would get 1 point something. One point three. All right, so it would have 1 carbon. So that's CH3 plus. All right, note, so to make things even easier now, these fragments, all right, so let me just put a note. Erase where, all right, just put it here. So basically, these, hold on, let me see the comment. All right, how do I determine the number of hydrogens? All right, so for the molecular ion, right, we had determined that it had 5 carbons. Good. So if the mass of the molecular ion is 72, and it has 5 carbons, C5, that is a mass of 60. That means 60 from the 72 is 12. All right, let me just put the question on the board for you. Yes, a plus should be on the molecular ion as well. So let me use an example to explain. So for 72, so to get the amount of hydrogens, we're always adding up the mass of the carbon atoms and then subtracting it from the number. So for example, for 15, right, if we say we have 1 carbon atom is 12. So 12 from 15 is 3. For fragment 43, if it has 3 carbons, 12 threes is 36. Therefore, it would have 7 hydrogens.